In the veiled depths of the solar system lies an enigmatic mystery, Neptune's elusive moon, Triton. Buried in darkness, the seemingly lifeless moon hides features that defy explanation. Unlike other satellites, Triton orbits Neptune in the opposite direction to the normal, defying the cosmic order. Its cold surface is surprisingly young and occasionally flashes with cryolava, revealing an otherworldly dynamism. Beneath the ice, shrouded in mystery, lies a dense layer that could be covering a bottomless ocean, a realm where extraterrestrial life may be kept secret. Come with us on this extraordinary odyssey to the outer reaches of the solar system, ready for a cold but exciting journey into the unknown. Neptune, a blue icy giant pierced by endless ultrasonic winds, is one of the most distant planets in our system. Not counting Pluto, it is the only planet we cannot see with the naked eye because of its dimness. 14 satellites orbit the icy giant, along with Triton. The strange, icy satellite was first discovered in 1846 by British astronomer William Lassell through mathematical calculations rather than direct observation, due to the imperfect optics for such distant objects at the time. Triton immediately attracted the attention of the scientific community because of its differences from other satellites. All of Neptune's moons are much smaller and, except for some outer satellites, move in the direction of the planet's rotation, while Triton rotates in the opposite direction, retrograde. In particular, scientists have noticed that the satellite is unusually similar to the famous dwarf planet Pluto. Their masses, diameters, and even the materials that make up the surface are very similar. But we'll talk about what role this plays for Triton a little later. The diameter of the unique satellite is 1,680 miles, which is almost 7 times larger than the second largest satellite of the ice giant, Proteus. Its size allows it to maintain a thin atmosphere, which is mainly composed of nitrogen and methane. On top of that, the satellite's upper atmosphere has an ionosphere, a place where atoms and molecules are ionized and more intense than on Earth. These factors are crucial for suggesting that Triton, like Pluto, may also be an icy dwarf planet. In addition, the ratio of rock to ice on the satellite is in the range of 70 to 30. This adds even more evidence to the planetary nature of Triton, and in particular hints at a different origin from all other satellites. It is therefore suspected that, like Earth, Triton has a crust, a liquid mantle, and a rocky core. Because of its distance of 2,793 million miles from the Sun, Triton is one of the coldest satellites in the solar system. The average temperature there reaches -400 degrees Fahrenheit. The surface of the satellite is covered with a layer of frozen nitrogen, under which there is a thick layer of ice mantle. All of this gives it an icy luster that reflects about 70% of the sunlight that hits it. Over a long period, in particular, its surface may be quite young, which also hints that Triton is not a dead stone at all, but a rather geologically active planet. Triton has a very interesting dynamic history of its surface development. This outer layer has many small impact craters, although they should be much larger and deeper. This suggests that the satellite may be recovering. In addition, when you look at Triton in detail, you can see large ridges and valleys with complex patterns that look like the skin of a melon. Smooth black stripes in some parts of it, however, do not seem that they could have been formed only by crashing space objects, because then Triton would be covered with huge impact basins. Therefore, astronomers have one possible answer to this characteristic landscape. A huge ocean may be hidden under the ice layer. Triton's surface is rejuvenated by a mixture of water and nitrogen that settles on its outer layer. But how does water appear on the surface? There are only 2 ways for water to fill the satellite's surface. Water can be poured out through strong meteorite impacts, or it can erupt through volcanic plumes in the outer crust. This is also hinted at by Triton's amazing nitrogen polar cap. Their formation depends on cryovolcanism. But wait, how can water erupt on such a cold moon? Triton is strongly influenced by Neptune's gravitational pull, which deforms the satellite's core, causing tidal heating that heats the water inside. In particular, solar heating can also be the cause of cryolava eruptions. Solar radiation passes through the ice, heating the subsurface nitrogen until it escapes through the crust. Water eruptions on Triton can last for more than a year, spewing tens of cubic kilometers of matter to restore affected parts of the surface. Heidi Hamel, a senior researcher at the Institute of Space Sciences, believes that such high geyser eruptions require a powerful source of heat and an ocean. However, the existence of the ocean has not yet been confirmed. There are several hypotheses about the nature of such a young surface. For example, heat from inside the satellite can melt pockets of nitrogen ice, which then erupt outward. In particular, cryovolcanoes may be fed by water not from the subsurface ocean, but simply from pockets of water in the crust. Triton raises many questions about its internal composition, and the only way to find out for sure whether Triton lives up to its name is through missions to the edge of the solar system. The first telescope to take detailed images of Triton was Voyager 2 in 1989, flying over Neptune's North Pole. Voyager bent its trajectory due to the giant's gravity to reach Triton at a distance of 25,000 miles, almost at the altitude of geostationary satellites. The telescope captured the very first images of Triton's surface and then departed forever into deep space. It's thanks to these images that we know so much about the mysterious satellite today. The Voyager mission provided a comprehensive characterization of the satellite, including its mass, atmosphere, and composition. For example, it was the mission to Triton that established that the atmosphere is dominated by molecular nitrogen with a small content of methane, which suggested that the satellite could be geologically active and gave rise to the study of the nature of eruptions. In particular, Voyager 2 proved that there are no oceans of liquid nitrogen on Triton's surface and showed the world the features of the satellite's surface. However, the mission to Triton saw only 40% of the satellite's southern hemisphere and only one side of it, because the satellite itself is always turned with one side toward Neptune. Almost 33 years after Triton's first image, the Space Telescope James Webb took a new, equally impressive photo of Neptune and Triton, albeit at a much greater distance. Webb has captured the barely visible rings of Neptune and its 7 moons for a very long time, but the largest moon of the icy giant has taken all the attention. To the left of Neptune in the image, you can see a very bright, star-like object. But it is Triton. Such an outburst of the moon confirms its shiny surface of condensed nitrogen, which reflects almost all the sunlight that gets there. Although the photographs taken over the past 30 years have greatly advanced our knowledge of Triton, there's still not enough to build a complete map of the satellite and answer the most intriguing questions. Therefore, more expeditions to Triton are needed to make sure that all the guesses are correct. Triton's unusual orbit seems particularly interesting for further research. As we've already mentioned, Triton is one of the few satellites that moves against the direction of Neptune's rotation, a retrograde motion. Retrograde motion, or counterclockwise motion of cosmic bodies, is rare. Only a few satellites in the solar system, like those of Uranus, Saturn, Jupiter, and Neptune, have retrograde orbits. Moreover, Triton is also tilted by 23 degrees compared to Neptune's flat path as it rotates. Usually, this tilt and reversal of motion is a result of a collision with another body. Therefore, some other object could have collided with Triton in the past in the same way and caused the retrograde motion. However, this version is not currently popular in scientific circles. In particular, this scenario does not explain the size and similarity of Triton to dwarf planets. So, what's the main reason for the satellite's alien nature? Neptune's orbit passes right on the border with the Kuiper Belt, a region of the remnants of the solar system and its actual border. It's there that the dwarf planet Pluto is located. There's another possible reason for the formation of a retrograde orbit of a space body. An independent object, moving at a certain speed and direction, can be captured by another body with a greater gravitational pull. Since it's difficult to model the conditions under which Triton could have formed organically around Neptune, scientists have concluded that Triton was probably captured by Neptune's gravity into its orbit. Now, scientists believe that the satellite could have been an object independent of Neptune in the past, once part of a double planetary system like the Pluto-Charon pair. The gravitational pull of Neptune is much greater than the relationship between two gravitationally bound small objects, so Triton could have become detached from another space body in part by changing its orbital velocity. It's believed that Triton was headed for a collision with the icy giant, but its companion planet could have brought it into Neptune's orbit, only to be ejected from the solar system. But this lost planet was not the only victim of Neptune's gravitational pull. As we mentioned, 13 other satellites are orbiting Neptune, divided into two groups, internal and external. Absolutely all of them have a very small mass. For example, Triton's mass is 99.5% of the mass of everything around the icy giant. Thus, Triton's migration could have destroyed Neptune's previous moons, leaving only small fragments behind. But this applies mostly to inner satellites, as they could have collapsed under Triton's influence and then reformed into other moons. In any case, Triton is still gradually getting closer to Neptune and, under the influence of its gravitational field, will eventually break apart and turn into a new ring system like Saturn. Despite the icy surface, Triton may harbor a warm ocean under its thick ice, and such a place could be favorable for the existence of life. There is a key condition for the development of life on a space body: water. Water is crucial for almost all biological processes, so it should come as no surprise that scientists are particularly interested in this component of Triton's composition. The presence of cryovolcanic plumes on the satellite suggests that there are enough carbon-based materials in the atmosphere, the key building blocks of living organisms. On top of that, Voyager 2 has already detected geysers on the satellite, which erupt at a height of 4.8 miles. However, there are still major obstacles that life cannot bypass. The extreme cold of the satellite would not allow life forms to evolve over billions of years into complex organisms. But still, Triton seems to have some periods of global warming. Changes in the nitrogen content in its polar region suggest that Triton undergoes seasonal changes similar to Earth's. But unlike Earth, Triton has about 40 years of summer. This means that it is possible that the moon is warming slightly. Although these changes are not large, it could explain why Triton remains geologically active. If the thick ice layer thins enough to expose more of the surface to solar radiation, Triton's nitrogen atmosphere could expand, and its internal heat could accumulate enough to create the conditions for life. Triton is an exciting object that leaves scientists with many questions about its geological activity, its hidden ocean, and even its potential for life. Many missions have been proposed to better understand the icy moon. One such mission is NASA's Triton, designed to investigate the existence of water and life on Triton. Although the mission was delayed indefinitely, the possibility of life beyond Earth keeps scientists enthusiastic.